All right, lesson 1-5. Polynomial functions and complex zeros. That's what we're going to call it. Today we're going to learn about factoring a polynomial function. Specifically, why we factor is because once we factor it, it's easier to identify key characteristics. So we're going to factor both using some techniques I'm going to show you using algebra, and then I'm also going to show you how to do it with technology, meaning with the graphing calculator. So it's the easiest with the graphing calculator. Here's the problem. The AP test, some portions of your test is with a calculator and some is without a calculator. So this is a topic you have to learn both by hand and by calculator. This topic here, this is one of those that they've told you is going to be tested in both areas. So I want to show you both. Calculator is much easier. Unfortunately, we don't always get to use it. So with that, we're going to start off with factoring polynomial functions. Again, you have these vocabulary words, but I'm not going to spend time here. It says before we move on, let's talk about what the types of numbers we have are. So I'm going to go quickly through this list. A natural number. This is how you learned how to count naturally. How many of you, when you learned how to count, were taught, hey, 0, 1, 1.5, 2. No, you weren't taught that way. How do you learn how to count when you're a kid? 1, 2, 3, whatever. You start with what number? 1. You start with 1. That's a natural number. You start with 1, and it's only the whole numbers. So I just gave you the word for the second set. What is a whole number then? Whole number includes 0, but still there's no decimals, there's no halves, there's no 3/4. It's just pure counting, but now you learned that there's such thing as 0. I can have nothing. Okay? Go into integers. Integers when you throw in the negatives. And there's symbols for these. I threw them in on a different slide. But as you go, natural numbers has a symbol of a double N. If you see this, I'm going to do the double N that way. Whole numbers. I'm blanking. Is it a W? I'm going to have to cheat and look. Whole numbers is a W. Yeah, it's like a double W, so I'll just do a double N on that side. Integers, believe it or not, is a Z. So that would be the symbol there. A rational number. Anything that can be written as a fraction. This takes the letter Q. I'm going to do the double Q there. That is a Q. Again, you have these symbols later. So I'm going to go through this quickly. Just add them. Irrational number. Irrational number. This is what they call the letter I believe. Check one more time. Irrational says I. Yep. That's what they call I. And that's why Z is for integers when we do double I there. Real numbers. This one you should know. What symbol is a real number? That double R. You've seen me write it already this year. Real number. Pure imaginary. They're going to call PI, and I'm just going to leave it like that. You're going to have a lowercase letter I. This comes from the square root of a negative number. That's how we do that. And finally, complex numbers. I don't think we have a letter for that. Complex is when it has a real and imaginary put together. So write this. Point at the A. Say real. A is a real value. B is a pure imaginary. I'm just going to put imaginary. Imaginary. Is that how you spell that? Imaginary. So it has a real and an imaginary part. Now the slide that I was looking at to get my letters is right here. This is just showing you a complex. A complex number is one that involves a real plus an imaginary. A complex number involves a real plus an imaginary. Now among the reals, again this is that double R. Among the reals, you could be rational or irrational. Irrational is anything that is a decimal that does not repeat. So I know of one that does not repeat. What is a number and you know of it too? Okay, there it is. It goes on forever and it does not repeat. Pi. Pi is a great example of an irrational number. That would be pi. Does not repeat. So let me fill this in with this. Here we go. So I can write a little bit more detailed with this. So irrational does not repeat. Repeat decimals. Phone up. Chris. And never terminates. Do you know what the word terminate means? No. Stops. It never stops. So it goes on forever, but it does not repeat. Rationals would be the opposite. It either repeats or the decimal stops. Repeats or stops. It either repeats or stops. The decimals. Let me put this. Decimals. Repeat or stop. There we go. Integer, there is no decimals but involves negatives. I'll put uses negatives here. Just trying to fill out this chart so you better understand it. Includes 0. Wholes include 0. And natural, the way you learned how to count. How we count. So that's how you make up the number system. Okay? So that'll come into play throughout the year. Again, on the right, there's the letter list that you'll see. I should say includes 0. There you go. Make my English proper. And to make my English proper, I shouldn't have said uses negatives. It's a double plural. Use negatives. Okay. All right. So let's go through and list these. All right. There's a whole bunch here. Let's start with 12. What's the most basic set that 12 would belong to? Natural. Now, I don't want you to be confused. If you're like, well, it's also whole, that's true. You're trying to say, what is the lowest set that it belongs to? Natural. So on A, we're going to say that is a natural number. So you can just do an n or a double n if you want. I'm going to do a double n there. Okay, what about B, square root of pi? Irrational. I've already told you that one. What the symbol was for irrational? There it is. And technically it should be a double I, so I'll do that there, like that. Okay, and it looks like a Roman number 2. What about this one? C. It's a fraction, also known as a ratio. Hint, it's rational. Do a little double Q there. Okay, what about D? Now there is a pattern, 1, 2, 1, 1, 2, 1, 1, 1, 2. But is it repeating? No, it's a pattern but not repeating. So if it never terminates, that's what dot 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 means, and it does not repeat, what do we call it? Irrational. This is irrational. Okay, what about negative 1? Integers. That would be the double Z. All right, 3/5. Rational. Okay, 4I. I stands for imaginary. So this is a purely imaginary. Why it's purely imaginary is it doesn't have a real number with it. You might say, what about the 4? Yes, what I'm talking about is like a 3+ or a 2-. If it's complex, complex is a real and an imaginary separated by either a positive or negative. What about 0? Now, why would we not say natural numbers? You don't learn how to count with 0. Okay, what about 0.3?
Rational.
It is rational. That would be it. Because 0.3, you can write it as a ratio. It terminates, stops. What about 1.32 repeating? Nope, it repeats. If it repeats, by the way, the reason it's rational, if it repeats, you could write it as a fraction. If it does not repeat, you cannot write it as a fraction. So some people think of pi being 22/7. That's close, but it's not exactly 22/7. Let me show you. Go to the calculator real quick. I'll just type it in. I'm going to calculator. There's the pi button in the bottom left. I'm going to press enter. Here's the number, 3.141592653539. Does it seem like it's repeating? No. Now I'm going to do 22 divided by 7. And I want it to change to a decimal, so I'm going to hit Control Enter. Now they're close, but are these exactly the same? 3.142, no, it's not. So even 22/7 is not accurate. So it is, where am I?
J.
I don't remember why I was talking about pi, but that's why it's irrational as opposed to rational, because it's not a fraction. Okay, moving on. K.
Imaginary.
This has imaginary and it has a real number 5, so this is complex. Good. Complex. And finally, last one. Give you a hint. Type that in the calculator. It's not an integer, so it's negative. Type in, do y'all know how to do fourth root? Right next to, you see the square root in blue there on my screen? Just to the left of it, which is control power button, you can type in a fourth root like that. 4, and then type -3. Press enter. What does it say when you do that? Error, non-real calculation. That's because this is imaginary. On the board, I wrote it on the domain rules. Rule number 2. Look over my board. What's rule number 2 say over there in between the flags where you see the cannot take an even root of a negative number. This number 4 is an even root of a negative number. That's imaginary. Oh, and I didn't realize it was 32. My bad. Typed in the wrong thing. It still gives you the same answer, but what this is, if I'm not mistaken, this would be -2i. Maybe, maybe not. -2 square root of I think. I don't know. It's kind of got me confused with exactly that would be, but I do know it is purely imaginary. But what the final value would be, it's either 2i or 2i. What's up? Go ahead. All right, moving on. So all that is a setup for what we're factoring polynomials. Like, how is all that a setup? Well, I'm going to show you here. There are things when we factor, we're going to come up with known as roots or zeros or solutions. So here, highlight some vocabulary. We're going to find when we factor roots, zeros, or solutions. They all mean the same thing. Notice the math is exactly the same. What do they all say on the left? X equals A. These are all synonyms. Oh man, synonyms maybe? I don't know if that's how you spell that. Someone could do a Google. Synonyms, that just means they mean the same thing. Someone could Google that for me. I don't know how we're supposed to spell that word. But synonym. Now another way is saying if A is real, you could write it in this form. What it's saying is all these things are x-intercepts. It'll be an x-intercept at the value of A. Notice that A is the x value, so it's an x-intercept when y is 0. And finally, we get to the key word that we're going to get to. We'd call this a factor. You will hear me say this all throughout the year. If x or y is in a parenthesis, they will be liars. What do I mean by that? Up here, it says x on A, B, and C. It says x equals what value? A. That's what x actually equals. But if you see in the parentheses, it will not look like x equals A. It'll be x, in this case, minus A. What has happened? My positive A in A, B, and C has become a negative. If it goes in parentheses, it's going to be a liar. If you're like, why is that the case? Well, simple math. It is simple algebra. Right up here, x and A are on opposite sides. If you wanted them to get on the same side of the equation, what would you have to do to move this A to the left? You'd have to subtract it. And so what happens when you subtract A is you're left with x minus A equals 0. And what do they call this right here? A 0. Now that's why. Now notice I just switched from x equals A, what was given in that part A, B, and C, to how it's written on E. X minus A, and they would put a parenthesis around it because it'll be multiplying. So that's the terminology that we'll be using. With all that, let's get started. Example 2 here. It says, given this function f of x equals x squared minus 4, we set the function equal to 0 to solve and get x equals 2 and negative 2. So this is just for your notes more than anything. So go ahead and draw circles here. Put x equals 2, x equals negative 2. That's our zeros, or roots, or solutions, whatever you want to call it. Now, how we would factor this equation from a picture. I'm about to show you, I'm going to go in the opposite order. I'm going to show you from the technology picture. We know the equation originally is x squared minus 4. Now here's how you'd write it from the picture. If you see a 0 at x minus 2, that means it came from the factor of, you solve for the, you set it equal to 0 and solve. How do you get rid of a minus 2? This would become x plus 2. So notice it's a lie. They're liars. And this 0 would become x minus 2. So that's how this equation would factor. Now that's how you do it from technology. It would look like that. Now this 0 becomes this factor. And this 0 becomes that factor. There was the original equation. From a picture, you can tell where the factors must be. All of this is telling you that information. So again, this is just for notes. We haven't actually started doing the math. That's just for you to look back on. That's clean, cut, you can see. Now let's start with some actual math. Let's do this. All right. Here's the rule from the bell ringer today. This here, you could look at the picture and tell me, is it an even power or odd power?
Even.
It's even. How do we know it's even?
Because both are up.
They both go up, so it has to be an even power. This equation has what power?
6.
6. Now, does it have 6 zeros here?
No.
It only has 3, but the maximum it could ever have is 6. So it says here, it has at most, whatever the power is, that many zeros, and one less extrema. And again, if you want to write this on your notes, what this is saying is, if your degree is n, if the degree equals n, then, let me put the word if. If the degree of the function equals n, then at most, this is what this is saying, at most n zeros, at most n minus 1 extrema. What's an extrema mean? Minimums or maximums. And at most, how many inflection points? What's n minus 1 minus another one? N minus 2 inflection points. Now they didn't write that on there about the inflection points, but I'm going to go ahead and put it for our notes. Now, at most means literally that, at most. Doesn't mean that will be the case, it just means the most you could potentially have. As shown in this picture, we only have 3 zeros, despite the power being 6. This one only has 3 zeros. It has 1, 2, 3 extrema, and would have 1, 2 inflection points. Okay, so here you go. Example 3. State the number of possible real zeros and relative extrema. Okay, so tell me on this one. What is at most, or how many possible real zeros are there? Let's do it that way instead of saying at most. Possible real zeros? Y'all said 3. So how many possible extrema?
2.
And how many possible inflection points then?
1.
All right, we'll write those in as we go. So now let's determine all the real zeros by factoring. Now here's how I'm going to do this. I have a set method. The first method I look for is GCF. I try to use GCF factoring first. Now we did this on the very first day of school. When I was introducing you in my class, we did GCF. What does GCF stand for, Dulce? Greatest common factor. We're looking for greatest common factors. Yeah, you can take it here. So greatest common factor. When you look at this equation, do you see anything in common all the way across? X. So we're going to take out the factor of x. So GCF is the opposite of distribution. Instead of multiplying through a parentheses, you're going to divide out to create a parentheses. What? We said x is common all the way across. If I divide out the x, what's left over? What's x cubed divided by power of x?
X squared.
X squared. What is 5x squared divided by x? 5x squared divided by x? 5x. And then 4x divided by x?
4.
Okay, so I first try that. So we have factored, but we can factor further. We're going to factor until everything is a linear. We factor into what's called linear combinations. What that means is until you only have powers of 1 on every x. Now, I still have an x squared, so I can factor further. Yeah, go ahead, Chris. So the second method I use, so that's technique number 1. The second technique I use is X method, is what I call that. So this is a second technique of factoring. And it's made up of 4 steps. Now you first have to do GCF. The second step, what you do is you're going to draw an X, and we're going to put the values of A times C on top and B on the bottom. Now you might be going, what is A, B, and C referred to? Well, those come from ax squared, the coefficients. A is the coefficient from the x squared, B is the coefficient in front of x, C is the coefficient, or the constant that's all alone. In this problem, here is my A, B, and C. So what is my A if it doesn't show me a number?
1.
So it's 1 times 4. What's 1 times 4? 4. That goes there. And my B is 5. Now we're looking for 2 numbers that have a product, that means multiply. They will have a product of 4, and a sum of 5. So I hear 4 times 1. Now what's wrong with 2 times 2? Their sum would be 4. So I always do, the way I do it, I do product first. What multiplies me 4? The only options are 2 times 2 and 4 times 1. And then say which one has a sum of 5. And the answer is 4 times 1. Now what you do, so that would be technically third step. First, you GCF. Second, you do X method. Third, what you do is you split the A term's power. So here I'm going to take this function down, but instead of having 1 parentheses with this x squared, what you do is you split this power. So I'm going to split it here, and I'm going to split it in another parentheses here. So when I split it, instead of it being x squared, it now becomes x and x, and then you put in these side numbers, plus 4 and plus 1. Now the last step, you don't always have to do, but if we have an a value bigger than 1, you have to divide out the factor a. Now in this case, there's nothing to divide out because my a is 1. You can divide anything you wanted to by 1 up there and it won't change anything. So that's actually going to be my final factor form right there. So using X method, we have just changed the equation to say f of x equals x times x plus 4 times x plus 1. Now why do we need to do this? Why is it helpful? Because we can now, this is factored form, we can state what the zeros are. We have 3 zeros. Now you're going to get used to me saying this all year, that x is a liar when it's in parentheses. This x is all alone. That produces the 0 at 0. Let me draw my arrow at the better place. We have 3 zeros. That's 1 at 0 because it's all by itself. This would have a 0 of not positive 4, but negative 4. And this one here is at positive, not positive 1, but negative 1. Now, if you're wondering why that's the case, you can later go home, just write this down. You can Google 0 product property, and you can learn this from Algebra 2. In Algebra 2, you learn that if you're multiplying and you want to find a 0, that means multiply and get a product of 0. There's only one way to multiply and get a product of 0. What is it? By 0. And so what they would do is they would separate each of these factors and say, okay, x by itself equals 0. Solve that. X plus 4 equals 0. Solve that. X plus 1 equals 0. Solve that. And that's how you would get your zeros. That one's already solved. This would become negative 4. This would become negative 1. That's where that comes from. Just Google this later if you want to. 0 product property from Algebra 2. And that's where I got those zeros from. Algebra 2. 0 product property. And that's how we solve. Now there will be another method of factoring that I'm going to show you as the lesson goes on today. But that's how we do it. Now how many of you does that review doing something like X method? How many of you have done something like that before? Remember? How many of you do not remember doing anything like that before? Just one? Okay. Well, let's go on and keep practicing then. Chris. All right, this one, I'm going to go a little faster. How many possible zeros? I want to say PZ. What does BZ stands for? Possible zeros. You saying 4? I agree. How many possible extrema? 3. And then possible inflection points?
2.
All right, great. Determine all real zeros by factoring. Okay, what was our first method we looked at last problem? GCF. You always do GCF first. It's the easiest, and it's necessary to perform the other ones accurately. Do we have anything in common here? This x to the 4th, negative 13x squared, 36. Do I have anything in common? No. So put NA. No GCF. So what's the second method of factoring we might try? X method. Okay, after GCFing, you come back and I'm going to look at the values here, A, B, and C. Draw an X. What goes at the top of our X? A times C, and on the bottom? B. Okay. What is, my A is, if it doesn't show a number, 1. What is 1 times 36? And they need to have negative 13. Now, one more time as a reminder, what we're doing here is a product. And I do products first. And then down here, you're looking for a sum of negative 13. So what are the values that have a product of 36? What are the numbers that have a product of 36? I hear 12 and 3. 6 and 6. 9 and 4. And there's 1 and 36. I'll say them now in order, starting with 1 and 36. There's 1 and 36. There's 2 and 18. If you ever want a technique for it, just go in order. 1 times what? It's 36. 2 times 18. 3 times 12. 4 times 9. 5 does not go into 36, but 6 does. 6 times. So it's one of those sets. Now, which one can combine to give you a 13? I hear 9 and 4. 9 and 4. Those are the only, out of all those numbers, those are the only ones that can give you a 13 somehow. Think about it. 1 and 36, that's either a 37 or a 35.
Wouldn't it be negative?
We'll put in negatives in a second. I do that last. 2 and 18 give you either a 20 or a 16. 3 and 12 give you either a 15 or a 9. So you go through that 4 and 13. Now how do I make it a negative 13?
Both negative.
Both negatives. Okay. The third step of X method. So it always follows GCF. Step 2 is the X. Step 3, you split the A term's power. So what I'm going to do here is I'm going to split this power. So it becomes x squared. So notice I'm splitting the power. And x squared. And now you fill in the side numbers. What are my side numbers here? Minus 9 and minus 4. Good. So we have just and then if your A is bigger than 1, you would do what's called, Miss Lester calls it bottoms up. It'd be a reducing. We don't need to do anything here because A is 1. So I would rewrite it, and normally I would say, okay, let's factor it now. This is not linear, a linear combination. These are not linear factors. These are quadratic factors, which means I can still factor more. You can either factor more, or you can still solve it if you would like. Let's say you wanted to solve it. How many zeros would you have here? Anybody know? We're going to have 4. Now, if you want to do more X methods, you could. Just on as a side note, as X methods, don't let me lose you here. What value am I missing? A, B, or C on this? I'm missing my B. I don't have the X term. So it would be, what's 1 times negative 9? What are factors of negative 9 that add up to 0? Factors of negative 9. B is not there, so B must equal 0 because it's not there. What are factors of negative 9 that add up to 0? 3 and negative 3. Yep, that's going to be the factors this time. So this would become x plus 3 and x minus 3. And we do the same thing here. I'll do this one in blue. Again, what term am I missing? The b. So I'm going to put b as 0. And so you do this again. 1 times -4 is -4, and b is 0. This will be 2 and -2. There you go. So this is x plus 2 and x minus 2. Again, you split the a term power after you do the x itself. You split the a term power. That's what you do there. You split this power, and here I'm splitting this power. And that's how you get that. Okay, so how many zeros do I actually have? 4 zeros. Where are the zeros located? What about here? -3, followed by +3, followed by and +2. And those are in order. So first the 3, -3, that's the -2, and this is 2. And again, like I said before, if you wanted to look this up, what should you Google if you want this more in depth from Algebra 2? This is 0 product property. If you want to look that up later, that's what you Google to get your answer. I don't know if I made it clear what my answer was this time. Yeah, let me box that up so if you're looking back at notes, that is our answer to the previous problem. Okay. So you see me do it twice real fast. I'm going to let you try this one, and then I'll pick back up with you in a moment. So now let's look at the real zeros of polynomial function. When the powers of polynomial equations increase, meaning beyond a power of 2, X method no longer works. You need another technique. Let me rephrase. If you cannot GCF out a power, for example, example 5, can I GCF a power of X? No, so X method works if the power is 2 or less. Really, you do that when you have a squared power as your degree. But this one, your degree is 3, and I can't GCF out a power, so I have to have another technique. And so, what we could do is a graphing, or we can use synthetic. So that's what we're going to do here. So is this the same problem or a different one? Yeah, okay. So on this one, we divide out by a factor. Now, right now, you don't know how to choose a factor, so I'm just going to go to the graph and show you how you do it with technology, and then I'll come back to synthetic in a moment. So go to your graph, and so I'm going to go New Document, and we're going to graph this to figure out what the zeros actually are. So what was the equation one more time?
X cubed minus 3x squared plus 8.
Minus 3x squared minus 6x plus 8. Now, before I hit enter, what's the maximum number of zeros this graph could have? 3. It should be a graph that either goes down and to the left, up and to the right, or vice versa, up and to the left, down and to the right. Let's click it and look. Okay, how many zeros do you see? 3. I could zoom out a little bit. I'm going to hit just menu, zoom fit, so you can see how the graph looks. Wow, that was not good. I don't like that at all. Let me change this. How about to 50? And I'm going to change this to -50. Okay, so that's a better idea of the picture. So I'm looking at it. How many zeros does it have?
3.
And it gets that look what I'm talking about. Odd functions, odd degree powers. If the function has an odd degree, it'll go diagonal kind of like this across the screen, much like a line does it, cube does it. Anything with an odd degree will do this. So we have 3 zeros. The zeros are located at, just for the sake of notes, I'm going to go ahead and analyze. You tell me, where's the first 0, left or right? -2. I should get a -2 here. What about the next 0?
Positive 1.
Positive 1 is correct. And the last one?
Positive 4.
Now, at this stage, I'm only using technology, and I'm finding these zeros. What I'm now going to show you is how the method that we'll also use, but you won't know how to pick the numbers just yet. So for a moment, I'm going to come back over to my graph here, and I need to take this. All right, here we go. Now I can. Okay, so what I can see here are where my zeros are. Shortcut. I'm going to skip to the end. When you look at a graph, the equation, the form would be f of x equals, and I'm going to use the letter A out in front. I'm going to use a capital A times like this. This is basically the format that it's going to come in. Every problem will come in this type format from a graph, meaning you'll have some coefficient out in front, but then you just have your zeros, your roots, that you can see to fill in. So that's like the basic form. And when I get to the very last slide, we'll talk about the capital A. Until then, we're going to ignore that. On this problem, where do you see the zeros? What's the first zero you see? -2. So here's how this one would look. This one would be f of x equals, instead of saying x minus 2, we make it a liar and say x plus 2. And then instead of plus 1, positive 1, it'll be minus 1. And then finally, x minus 4. Now that's how the equation will graph. This is our final answer here from technology. Now you might be going, well, what about that capital A out front? We'll do that in the very last question. For now, I'm just going to leave it like that. And I know it's correct just because I see here there's no number out in front. So I know that's going to be the final answer. So how could you get this mathematically? Well, if you knew what a zero was or knew a good number to guess by, you can use synthetic division. That's what I'm going to do here. Here's how synthetic division works. I'm going to use this first zero of -2. Write -2 and draw like a backwards division line box. So usually we divide into something, and when the house goes up and over, this one go down into the side like that. Now you're going to fill in your coefficients. How many x cubes do I have? Nope. How many x cubes do I have? 1. So you just put the coefficient. I have 1x cubed. Now how many x squares do I have? Not 1.
3.
-3. Put a -3. Now, by the way, if it wasn't there, you would put a 0. You had to have a placeholder. How many, you subtract the power. That's x cubed, x squared. How many power of 1 x's do I have? -6. And finally, my constant at the end is a +8. Now, leave a space and draw a line, because we're going to fill in a number. And here's what happens every time. Your first number will drop straight down. And as Ms. Lester says, you follow your mama when you do synthetic division. What that means is you first multiply. You multiply this number with -2. What is 1 times -2? Now that goes there. Now why she says follow your mama is because you multiply, then you add, or you could say combine, but MC doesn't make any sense. So I'm just, what is -3 and -2? -5. Now, after we added those together, you're back to multiplying. -5 times -2 is +10. Totally agree. So put a +10 there. So what is -6 plus 10? 4. Now, after you add, we're back to multiplying. What's 4 times -2? Now, if it's a 0, your last number should always be 0. Is it? Now this is what we call in division the remainder. Do you remember that remainder?
Yeah.
Now we're going to call it in my class r of x, just meaning the remainder, because it sometimes could be a function. So 0 is r of x. If you get 0 there, this is a factor. This means x equals -2 is a 0. X plus 2 is a factor. Since the remainder equals 0. Because a remainder equals 0, x minus 2 is a 0, and x plus 2 is a factor. Now, why do we do synthetic? Here's what happens. This was originally an x cubed power, was it not? When you drop it down, it loses a power. So this becomes x squared, and that would become a -5x, and this is a +4. Well, from here, you can x method. You could keep doing synthetic if you wanted to. but I can now do synthetic. So this is, we've simplified f of x. At this stage, you could rewrite it and say that f of x would equal, we found that x plus 2 is a factor. X plus 2 times x squared minus 5x plus 4. Now I just got that from right there. And now we could x method. So if to factor this, again, we have to get these factors right here. This is still quadratic, but if it's quadratic, I do x method. You first look for a GCF. Is there any GCF there? No. So now we do a times c. What's a? What's my? Here's a, b, and c. What's 1 times 4? And b is -5. What are factors of 4 that add to -5?
Negative 4.
So you're saying it's not including. Ignore the negatives for a moment. It's not 2 and 2. It's got to be 4 and 1.
Yeah.
Okay. And then what makes it a -5?
Well, negative.
Both negative. And so that would be rewritten as, when you split this power, it becomes x minus 4 and x minus 1. And I forgot to write this x plus 2. Let me rewrite it now. Order doesn't matter. And notice this right here is exactly the same I had boxed up earlier. Right there. These are exactly the same answer. I just did the different order, but the answer is the same. So that's how you do it by hand. The problem is you don't know what to divide by. How did we know to divide this by -2 synthetically? We use the graph. Now what happens if you don't have a graph? That's what we have to talk about. But that's how you use synthetic division. Make sense? So what we're going to do for practice sake today is each time we're going to just look at the graph and we're going to know what number to divide by. And we're just going to practice doing that math. And then for next class, we'll talk about how do we come up with what number to multiply without technology. Okay? So let's try our next problem. On the next one, it tells us what the factor is. We don't have to graph it. So what you'll do first is you have to solve x. This is the factor here. And so what you do is set it equal to 0 and solve. Because again, if it's a factor, it's like a parenthesis, it's a liar. So we have to solve. How would I get x by itself here? Plus 4. So 3x equals 4. And now we divide it by 3. Okay, so what we're going to divide by, and you know what? I'm going to correct one thing on the notes. Put here x equals, on the previous problem, put x equals -2. So you see where that number came from? You divide by a 0 when you do synthetic. You always divide by a 0 from the graph or the equation. So here, I'm going to divide by x equals 4/3. So draw your line over. What's our degree here? What's the highest power? 3. So how many x cubes do I have? 6. Put 6 first. Now you have to have every power, and if you're missing one, you put a 0 as a placeholder. So if that's x cubes, how many squares do I have?
1.
How many, just x's by itself?
-17.
And then the constant is,
140.
leave a little space, draw a line. Now the first number will always drop down. Here it won't end up being finally correct. I'll have to show you that in a moment. Okay, you have to now multiply, because again we follow our mama. So when you multiply by a fraction, really what's happening is you multiply the numerator, 4 times 6, and then you divide by the denominator. I like to divide first because it makes the number smaller. It's going to be right either way. I'll prove it to you real quick. What's 4 times 6?
24.
Then you would divide by 3 and you would get 8. But watch, if you divide first, what is 6 divided by 3? 2. Then you just multiply 2 times 4 and you get 8. It's easier. So that's how I'm going to do it. I'm going to divide first. Okay, so that we added, now, excuse me, we multiplied, now we add. What's 1 plus 8?
9.
9. So what is 9 divided by 3? 3 times that by 4?
12.
That goes there. Negative 117 plus 12.
Negative 105.
Negative 105. Good. Okay, you divide that by 3.
35.
We know it's a negative number. Oh, very good. It is 35. 3 goes into 10 3 times, remainder 1. 3 goes into 15, 5. It is 35. Negative 35 times 4.
Negative 140.
Negative 140. Now tell me, what did we just get here?
0.
Is that good or bad?
Good.
That's good, because if it's a 0, it means it is a factor or a 0. So we've just proven that 3x minus 4 is a factor. 3x minus 4 is a factor, and x equals 4/3 is a 0. Since the remainder equals 0. That's what we just proved there. Now, they told us that. We just proved it. Now, what you have to do, though, you see how this is a 3x here? Yeah, you see how that? And that was a fraction. Here's a rule. If your 0 is a fraction, on this portion, not this portion, that's why you have to do this last, you have to come by and divide it one more time by this number. Because, here's the because. When I drop down 6, it didn't get divided by that 3. And it should have. But if you divide it by 3 first, it's going to mess up the very end of the number. So you can't do it until you're done, and you only do it with the non-remainder portion. So we're going to divide it all by 3 because it was supposed to be divided by a 3x. 6 hasn't been divided at all. It dropped straight down. So now I have to correct that mistake. So just do, on the non-remainder portion, do divided by 3. Divide by 3. Divide by 3. That means our function is, it was a cubed. When it drops, it becomes a squared. X like this. Okay, what is 6 divided by 3? So it's 2x squared plus 3x minus 35. Good. Now I can use, truthfully, it should be this times 3x minus 4. Now they didn't name this equation, so I won't name it here. Can I now use x method?
Yes.
Yeah, we can. I like x method more because you don't have to guess. Yes, there's more. We got to get to a linear combination. That means linear powers. This is a quadratic power. What is a times c here? 2 times negative 35? Negative 70. And our b value? 3. Now don't pay attention to the negatives until after you write your numbers in. You're thinking of what can multiply to be negative 70, add to be 3, except ignore the negatives for a moment. Is it 1 and 70? 2 and 35?
No.
3 doesn't go into 70, 4 doesn't go into 70, 5 does 14 times. 5 and 4? 14?
No.
No. 7 and 10?
Yeah.
It's 7 and 10. Once you know those 7 and 10 are 3 apart, it's got to be 7 and 10. How do I get a positive 3?
Negative 7.
10 minus 7. So here we go again. We split our A-term power. So it's going to be a 2x. Just split the power. A 2x minus 7 and a 2x plus 10 times 3x minus 4. And this will have one more error fix. So I told you with synthetic, you have to fix an error. If you're dividing by a fraction, and we divide by 3, same is true for x method. If your a is bigger than 1, which this one is, we have an error because when I split the power, I wrote 2 2's. I'm only supposed to have 1, but I wrote it twice. So somewhere I have to divide out the extra power 2. Which one can be simplified? 2x minus 7? Can 2 divide into that evenly, or can 2 divide into 2x plus 10 evenly? Whichever one can be divided evenly, this is the last little step there. You divide that, and that will be the final answer. This is not a GCF. This is an error correction, so I'm going to totally get rid of this 2. It was an extra 2 we added to the problem when we split the power, and so I'll divide it out here. Some students just like to do the division over here. They'll look at it and say, which one can be divided by 2? And they'll say, oh, it's 10. So I'll divide that by 2, and they won't even write out the step that I did right there. But I did it that way so you can see it. That's an ugly 2. Let me erase that and do it one more time. Okay, that's a 2 there. So here's how our final answer would look. We'd have 2x minus 7 times x plus 5 and page one. That's the final factored form. Now that says to factor it, that's all it tells us to do. So I will say that's our answer. But I will list how many zeros would this have?
1.
3 zeros. There could be 3 zeros here. Where would the zeros occur? It would be actually 7, and then that 2 is multiplying, but it's a liar. 7 divided by 2? Negative 5, and this one we already did up here. Positive 4 divided by 3. That's where the 3 zeros would be located if you graph this function right there. Having fun factoring yet?
No.
Welcome to AP Pre-Calculus. You need to learn how to factor. Big lesson today.
Divided by 3 to make it
Yeah, let's call this here. The reason I divide by 3, this is an error fix, a synthetic error defect. We call this synthetic division. This is a synthetic error fix. And the reason it's an error fix is we were supposed to divide out, let me slide up just a little bit, 3x minus 4. And as far as the 6 goes, we didn't divide it at all. You see how we dropped it straight down? So you technically need to divide it by 3. Now you might be thinking, why did we not just do it at the start? Well, the reason is, it would have messed up this number, because did we divide this 8 by 3? No, it would have messed up every one of these numbers as well as our remainder. So you wait till the very end, you fix the error. Same is true with X method. This is an error fix as well. This is an X method error fix. X method error fix. And if you're like, well, where did that error come from? Well, when we split the 8 terms power, it was a 2x squared. I wrote 2x and 2x. Just think quick multiplication. What's 2x times 2x? That's 4x squared. That's an error. And so we had to divide out a factor of whatever your a is. If your a is bigger than 1, you'll have to divide out by factors of that a to fix that error as well. Now you might shake your head, but I promise within a month of practice, you might not be shaking your head, and within 3 months, it'll be like second nature. All right, just keep at it. That's all it takes. Is keep at it. All right. What do we have? Some more information here. Okay, so this is stuff I've actually already told you. Okay, so I'm going to leave that here. It's telling you it could be trial and error. All right, and we now have finally come to how do you figure out what numbers to divide by if you don't have a calculator. And that's what this is. It's called the P divided by Q test. Here's what I want you to write on your notes. But this is this right here, the constant. Put this as P. And this number, the a to the power a sub n as your q. Put that in your notes. So this is right here, what that's saying right there. That's what that's telling you, and this is telling you this portion right there. Okay, so let's just say you had no technology and you wanted to find out what are the possible rational zeros. What are the possible things that I could use synthetic for? Here's what you do. Identify your P and Q. This right here is what letter? P, and this is Q. The number right there. Now, what number goes there if there doesn't have one?
1.
What you do is you list out your possible factors. The factors of P, which is 4, and your factors, and it's going to be divided by, the factors of Q, which in this problem is 1. And they're always plus or minus. Let me do plus or minus here. So how would the list look? It's going to be a list. What are the factors of 4? Okay, so you could have 1 times 4. And I'm going to do it like this because this is proper the way to do it. You could have a positive 1 times a positive 4. You could have a negative 1 times a negative 4. Any other factors of 4? 2 and 2. It could be positive 2 times a positive 2 or a negative 2 times another negative 2. So I want to write plus or minus. Now you don't ever have to write a number twice. So you see how I have those lists with it twice? You don't have to include it twice. So cross out that other 2. Now what are the factors of 1? What can multiply and give you 1? 1 times 1. Do I have to write it twice? No. Okay, so now all we do is we simplify, if possible, as we rewrite this list. What is 1 divided by 1? 1. So plus or minus 1. What is 4 divided by 1? 4. And it could be positive or negative. And now what's 2 divided by 1? Okay, if you were going to do synthetic, these are the only possible rational zeros. Only possible rational zeros. Now you're like, wait a minute, what did that word rational mean? We talked about it earlier today, I've forgotten. Rational means a number that can be written as a ratio, as a fraction. It doesn't include pi. Pi is a never-ending decimal that never repeats, so that would not be rational. Any zero that this graph could ever possibly have is only positive negative 1, positive number negative 4, positive negative 2. Those are the only possibilities. All right? Let me circle that up so we have our answer, or box it up there. There is our possible rational zeros. All right, so let's take a look at example B. What would be our P? What value would be represented by P in this case?
2.
I hear 2. That's actually a Q.
No, Q.
That will be Q.
15.
Okay, so 15. Let's go ahead and mark that one. Oh, my board just went out on me. There we go. This is our P. That's our Q. So remember, it was factors of P divided by the factors of Q. Now, we're going to do a plus or minus every single time because you can have positive and negative factors here. So what are the factors of 15? What can we multiply to get 15?
5 and 3.
3 times 5. And it could be a positive 3 times a positive 5 or a negative 3 times a negative 5. So plus or minus 3, plus or minus 5. Okay, what other factors of 15 do we have?
1 and 15.
1 and 15. 1 and 15. Now, what are the factors of Q, the number 2? Just 2 and 1. I did it here in order of 1 to 2. So here's what this means. No matter what's on the inside, the only places that this function, this cubic function, I'm saying cubic because its degree is 3, the highest power is 3, the only places this could ever hit the x-axis and not be a never-ending, never-repeating number is one of these factors when you simplify. That's the only possibilities. It could never hit. For example, here I do not see the number 7. Do you see a number 7 up there? No matter what numbers you put in the middle of this equation, you could change up the equation all the way from today to the next time I see y'all on Friday. You can just keep messing with numbers. You will never find a cubic function that begins with 2x cubed and ends with a 15 that goes to the number 7. It won't do it. Positive or negative. It won't go through 7. How do I know it doesn't go through 7? Because it's not on our list. Would it ever go through the number 9? No. How do you know it won't go through 9? It's not on the list. Would it ever go to the number 4? It's not on the list. It can't do it. So the only possible numbers this could ever go through that are rational. I remember from last class, irrational would mean it's a never-ending number or never-repeating number. Never-ending, never-repeating. Now they could hit any of those numbers, but as far as rational, the numbers that either repeat or terminate, these are the only ones that could ever go through. Okay, so let's reduce this. I'm going to go in order of smallest to greatest. What's 1 divided by 1?
1.
So we do plus or minus 1, so now we're just reducing. 3 is next smallest. What's 3 divided by 1?
3.
So it could hit at positive or negative 1. It could hit at positive or negative 3 on the x-axis. Then 5 divided by 1.
5.
It could hit at positive or negative 5. And then 15 divided by 1. 15. Okay, there's half of our list. Now I'm going to do the same thing, but this time I'm going to divide by 2. 1 divided by 2?
1/2.
1/2. It could hit at positive or negative 1/2. 3 divided by 2?
2/2.
3 halves. That does not reduce. 5 divided by 2?
5/2.
And 15 over 2.
15/2.
So none of those reduce. However, if they would have happened to reduce and would have been a duplicate, you don't have to write down duplicates in this. So you do not have to write down duplicates. Those are the only places, those are the only possible rational zeros. Okay, so one more time. What does it mean to be rational?
The ending.
That it either has a, if it's a decimal, that it ends, or it repeats. So like 1/3 would be a repeating decimal, 0.33333333. That 1/3. So anything that can be written as a fraction will either repeat or come to an end as a decimal, if it has a decimal at all. So these are the only possible rational. That's the only places this could hit on the x-axis that would not be some crazy decimal. Only possibility for anything that begins with 2x cubed and ends with the 15. Okay, so now, why would we do this? Because sometimes if you were going to factor and you had no technology whatsoever, you'd be thinking, where do I start if I have to do synthetic and I have no idea what to divide by? You would come up with your list and pick numbers to divide by. Okay? Now, let's write out our rational factors. I'm still not yet at the point where we're just going to do this all class, but we are going to write out the possibilities. What are the possible rational zeros here? Possible rational zeros. Let's find those. What is my p in this problem?
60.
60. That's my p. What's my q?
6.
6. Okay, so what are the factors of 60?
30 and 2.
Okay, here 30 and 2. I heard 6 times 10.
5 times 12.
6 times, sorry. 10.
4 times 15.
I heard 5 and 12. That's a good one. I heard 5 and 15. I forgot the... Goodness gracious. 4 and 15? 4, 15. Okay, what else? 3 and 20. This goes on and on. What about 1 and 60? We got 2 and 30. Did we get 3 and 20?
Yeah.
We got 4 and 15. We got 5 and 12. We got 6 and 10. Does 7 go into 60?
No.
Does 8 go into 60? No. 9? No. 10 and 6. Okay, now we're repeating. So I just counted up the numbers. When I got to 10, we already have 10 and 6, so we're repeating. So that's all of them. Oh my goodness, what a list. Divided by, what are the factors of 6?
1 and 6.
1 and 6.
2 and 3.
And 2 and 3. And here's the deal. You would have to simplify that out. And that would take forever, wouldn't it?
Yes.
So rather than do it that way all day, I'm just going to write them out. We would need to simplify this, truthfully. And you wouldn't have to do repeating values. So why would I have repeating? Yes, I would. So for example, let me just give you a repeat. What is 3 divided by 1? 3. Later, we would have 6 divided by 2. What's that? 3. Later, after that, we would have... no, I don't have a 9 on there. Those might be my only 3s that I get. But as you can see, there would just be repeats. 10 divided by 1 is 10. 60 divided by 6 is 10. 30 divided by 3 is 10. 20 divided by 2 is 10. You won't have to do repeating. Okay, so the list would shrink a little bit, but that's a long list. So I'm still going to use our calculator. So let's go use some technology. We're going to go over... I'm going to go to graph, add a graph. If you have anything in there, if it asks you to save, when you hit the home screen, I would start off. I already did home screen before y'all walked in here today. Go to new document. If it asks you to save, hit no. Make sure we clear out everything that's there before. We started this equation. I remember it started 6x to the power of 3. What took place after that, I forget. Positive 17x squared. Okay. And then minus 104 x plus 60 or minus 60 at the end? Plus 60. Okay, I'm going to hit enter. Let's see if you kind of have put together some knowledge. What's the maximum number of zeros this graph could have? 3. So the maximum number is 3. Do we see all 3? Yes, we do. I'm going to extend this graph so I can see more of it. I know it goes as high as 60. That's the y-intercept. So I'm going to do 2 times 60. What is 2 times 60? I'm going to go as high as 120, and I'll go as low as negative 120 here, so we can see more of our graph. I'm going to go as low as negative 120. I still don't see the highest part of this graph. That's crazy how high this must be. I don't know. I'm going to try 500 now. Okay, now I see the graph. I'm as high as 500 and as low as negative 120, and I can see this. We have 3 zeros. Let's see if they're rational or not. Press Menu, Analyze Graph, hit 0, and let's find all 3 zeros. This first one appears to be at negative how much? 1, 2, 3, 4, 5. It appears to be negative 6. Let's check. Take your lower bound to the left of negative 6, hit click, or press the enter key, then take your upper bound to the right of it. Does it say negative 6, 0? Now, was that on our list? Did we have a 6?
Yes.
Yes, we did. A negative 6? We did. So that is rational. It's not rounded. We know that it's exactly negative 6. I'm going to do this again. Our next 0. What about this one? Now it says 0.667. Does anybody know what that is as a...
2/3.
It's 2/3. That's right. That's 2/3. That was on our list. There was a plus or minus 2 in the top, in the numerator, and a plus or minus 3 in the denominator. And one more time, I want to find the last 0. I haven't taught you this yet, but the irrationals and imaginaries always come in pairs. So if you have one that's irrational, you have to have a second that's irrational. If you have one that's imaginary, you have to have a second that's imaginary with it. Okay, so those are my 3. I'm going to take this picture, and now we're going to just practice synthetic, just to prove that this works out. So we said all 3 of these are rational because they're on the list. I didn't ask you, what is 2.5 as a fraction? 5 over 2. Yeah, we have 5 over 2 here. I'm going to just circle up the ones that turned out to be the case. We have 5 over 2. We had 5 over 2. We had 2/3. I'm going to switch colors here. We had 2/3. And we also had a negative 6. And again, you can get these from multiple places, but I'm just going to take, let me redo this. I'm going to do 6 over 1. We also had this one here, a negative 6. So yeah, those all came from the list. Now let's practice our synthetic. I'm going to go left to right. I'm going to start with negative 6. So if you chose x equals negative 6, I'm going to do synthetic division here. Remember, you start with your highest power, the coefficient. What's the coefficient of x cubed? 6, followed by positive 17, negative 104, 60. Draw your line underneath. First term always drops straight down, and then we follow our mama. What did that mean? Multiply first. What is 6 times negative 6? Negative 36. Now we add. What is 17? I know it's a minus, but ooh, I hear a 20 and I hear a 19. Which one's correct?
19.
Positive or negative?
Negative.
Negative 19. All right, bigger math here. Negative 6 times negative 19. I agree, because negative 6 times negative 10 is a positive 60. 6 times 9 is 54. 60 and 54, that would be 114. Positive 114. Okay, what is negative 104 and 114? 10. And then 10 times negative 6. Now, if this worked, we should have got 0 for our remainder, did we?
Yep.
Okay, now I put r of x, which just stands for remainder. And what happens here is this was x cubed, and when you drop down, it becomes x squared. Now, since this was not a fraction, I don't need to divide anything else. So I've gotten here. Now, we could go to x method if you like. Or you could continue on with synthetic. Since we know what the answers are, I'm just going to continue on with synthetic. What did you say 0.667 is as a fraction? 2/3. So I'm going to use 2/3 this time. Here's what I do. Right on this next line, right here, I'm going to put x equals 2/3. Leave a space, drop your line. Do not underline your remainder. So synthetic, it's going to drop straight down again. This is now 6. So it's 6 times 2/3. We did this last class, but with the fraction, I'm going to do it again. I like to, with mental math, divide first, then multiply. It just makes you have a smaller number earlier. What is 6 divided by 3? 2. Then you multiply it times the numerator. So 2 times 2 is 4. Put a 4 there. Negative 19 plus 4. Negative 15. Okay, negative 15, I'm going to divide first. What's negative 15 divided by 3? Negative 5. Double it, multiply by 2. Negative 10, Alexis. What do we get here? 0 for a remainder. Now, you have to have a remainder for it to be a 0. So that, I should have put that on there. This is a 0. This is a 0, or a factor. It tells you it's a 0 or a factor if you get a remainder of 0. This is good. Now this was x squared. So what's it become here? Now if I leave it like this, I'm wrong. Because I have to error correct. What's my error correction here? Since this is a fraction, I need to divide these by 3. Because technically the 6 should have gotten divided by 3. Did it? No. Now if you divide at the start though, it would have made this number wrong. So you have to wait. You have to wait till the end to divide, and you only divide the part that's not the remainder. Okay, so what does that mean we're left with? 2x minus 5, and I'm just going to solve this one without synthetic. I'm going to solve it. I'm going to solve this one by algebra 1. What would I do first to get this by itself? I have 2x minus 5. I'm setting it equal to 0. We would add 5 to both sides. And 2x equals 5 divided by 2. 5 over 5 halves. So we have our zeros. I'll just write this one over here. 5 halves. X equals 2/3. X equals negative 6. Were those all zeros?
Yes.
Yes, they were. So we found the zeros. And so you can write our final answer all together if we wanted to. Negative 6, 2/3, and 5 halves. Last class, I gave you all 4 different techniques for factoring. What was the first? I told you always should start with most basic of all factoring. Not X method, that was the second type I taught you. If the opposite distributed property, GCF, greatest common factor. Greatest common factor was the first type. The second type, y'all said it here, X method. Third type, in order that I taught you, was actually this calculator method. And then the fourth was synthetic. Here we did graphing technique and we did synthetic. Did they give us the same solution or different solutions? Same. Now if you were going to use this theorem, you would have to come up, this is where you'd come up with the numbers to divide by. You'd be guessing all day because there's a million up there. Okay? That's why I went ahead and just used the graphing technique. But that's what that's for, is in case you were living in Isaac Newton's time, and you had no graphing calculators, yet you wanted to do all of calculus like he did. You know, he basically invented calculus. I shouldn't say invented math. He didn't invent math. He just discovered it, how it works. That's what he would have had to do to solve these. All right? Breeza, this is for you. Okay, with that, let's try another problem. Okay, so we need to know this theorem. You need to know the theorem back and forth. The P divided by Q, that P divided by Q test. So which, on this problem, what is our P? 18. Put it, go ahead. Negative 18, okay, and Q?
1.
Q is 1, good. So what are the factors of negative 18? I'm going to write it this way to be more specific rather than say factors of.
Positive of negative 18.
And then I'll do the factors of 1 here. Okay, plus or minus 1 and 18 I hear. And the reason it's plus or minus, it could be a negative 1 times a positive 18 or a positive 1 times a negative 18. Okay, anything else? 2 times 9, good. So positive negative 9. 3 and 6. Again, our list is adding up. Can 4 go into 18? 5, 6. Yeah, now once I say 6, we're repeating, so I can stop there. Okay, factors of 1? Just 1 times 1. And negative 1 times negative 1. So this one, I'll go ahead and simplify. I won't just leave it in this form, because everything divided by 1 is itself. So I'm going to write them in numerical order, counting number order. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus, we skip to 6, plus or minus 9, and plus or minus 18. Those are the only possible rational zeros. So if you had no calculator, no technology, and you had to try to factor this. I didn't even ask this. Do we have a GCF here? Anything common all the way across? No. So I can't factor by GCF. I can't do X method because it's more than a trinomial. X method only works for binomials, trinomials.
What?
You can do a binomials with X method as well. You just plug in a 0 for what you're missing. What is a binomial? 2 terms. This is 4 terms. So you have to, you don't have to use synthetic, but it's the quickest way. So anyways, we're left with synthetic. Okay, let's go to our calculator and find out what they actually are. So we're not just guessing all day long. I'm going to go ahead and just press tab here and change my equation. Press tab and then up. And I'm going to change my equation. It was 1x cubed. I remember that. The q was 1. And I remember the p was negative 18. I never paid attention to what was in the middle. What is our b term and our c term? What did you say? How many x squares do we have? Negative 8. We have negative 8 x squareds. And then how many x's do we have? What's our coefficient there? Plus 21? Plus 21. So x cubed minus 8x squared plus 21x minus 18.
Let's do.
Hit enter, and what zeros show up for yourself? Please. Oh, you weren't writing on it? Oh, okay. I thought when you were erasing you must have been. All right. I see how many zeros? Only
2.
Oh, you got a second?
No, 3. No, wait. 2.
Do I need to zoom back in? I'm going to go menu, window zoom. I'm going to go back to the normal view. Zoom, standard. Okay. I agree with you. It shows more than 1 0 here. I got 1 at 3. And it looks like at positive 2 I also have 1. Now, I've heard other people saying 3. Where'd you find the third? I'm going to investigate. Because of a theorem I gave you a second ago, I said, I'm going to zoom in here to show you something closer. All right, I zoomed in on my calculator here. Now, how many zeros are you seeing there? 2. I'm going to show you something pretty cool about that one, though. All right. So we're seeing 2 zeros. 2 unique zeros is what we're seeing. And from our list, I'll go ahead and circle the ones we're seeing. We're seeing positive 2. And we're seeing positive 3. What this would mean is if I did synthetic with 1, would I get a remainder of 0 or would I not get a remainder of 0? What do you think? Pedro, what do you think? if I did synthetic with the number 1, what would I get for my remainder? Would I get 0 or a non-zero number? I'll widen this out. So I asked him, because I thought he was fading on me, if, according to this picture, if I did synthetic with 1, do you think I would get 0 as a remainder or a non-zero? No, it would be non-zero. Why would it be a non-zero number?
Because it's not a zero in the graph.
It's not a 0 in the graph. What are the only numbers in this list that would give us 0 when we do synthetic? 2 and 3. 2 and 3. Everything else will give us a different remainder. Would you like me to prove that to you? Yeah, it'd be helpful to see. Let's just take 1. We'll try 1 real quick, and then we'll erase it. Let's just say, what if you were like Isaac Newton, you just wanted to guess, and you said, okay, x equals 1. I want to try that. And so you write out your coefficients. 1, -8, 21, and -18. So the 1 drops. What is 1 times 1? -8 plus 1? What is -7 times 1? What do we get here? 21 minus 7 is 14. And then 1 times 14 is 14. What is -18 plus 14? -4. That's your remainder. Is that a factor?
No.
So I'm going to go ahead and just leave that here. Not a factor /0 since our remainder does not equal 0. Now here's what's cool. Little tip that smart people figured out is when you're guessing numbers, you see how when you divide it by 1, how they alternate? They went positive, negative, positive, negative. You see how it goes that pattern? If they alternate every way, that means there is a 0 greater than 1. All zeros are greater than 1 because it's alternating. Just a rule, you don't need to memorize that, I'm just telling you. So if you were to only doing the guessing game, because it alternated, would you pick a number bigger than 1 or smaller than 1? Bigger. And you look at the graph and you see that they are at 2 and 3. There's also a rule if you get too far back and that's past all the zeros to help you limit in where are they located. Okay, so if you're kind of in the middle, I don't think it follows a rule, but if you're too small or too big, there is a rule. In that case, if it's alternating, you're too small. All right, so we say 1 doesn't work. So what are we going to try this time? 2. Now, since this did not work, I can't start there. I have to start over. So we're going to do it again. This time, we're going to use x equals 2. And my numbers will still, my coefficients are going to return to 1, -8, 21, and -18. I have to start over, start fresh, since since that was not a 0, I have to start over. I cannot continue on from this division. So I start fresh, start over with f of x. So I don't use the simplified version. I'm going to start all the way over. Okay, 1 drops. What's 1 times 2? 2. -8. -6. -6 times 2. -12. 21 minus 12. Positive 9. And then 2 times -9. There we go. Positive 18. And so -18 plus 18 is 0. Is this a factor or a 0?
Yes.
All right. This is good. 0 factor. I'll go ahead and put the since in there. Since r of x equals 0. Okay. This was x cubed. What is it now? X squared. This would become an x. Now, do I need to divide this by anything? Do I have an error fix? No, because that's not a fraction. Okay, so we go to our next number. Now, let's just say we're looking at going, well, that's alternating. So what would you guess if it's alternating? A smaller number or a bigger number? A bigger number. What's bigger than 2? 3 is bigger than 2. So let's try 3. We try 3. Again, you could, at this stage, if you wanted to, do x method. But while we're practicing synthetic, I'll just stick with it. What is 1 times 3? 3 and negative 6 plus 3?
Negative 3.
Negative 3 and negative 3 times negative 3 is negative 9. What do you get?
0.
0. Is that good or bad?
Good.
That's good. This is a factor and a 0. Since the r of x equals 0. Now, do I need to do another synthetic? No. What are we left with? X minus 3 equals 0. And how do you solve that one?
You add 3.
You add 3.
And x equals
And x equals 3. So look at our zeros. What were our zeros? Was this a 0 or not a 0? Not a 0. So we're going to say our zeros are x equals 2 and 3. And for now, I want you to put in parentheses m2. You don't know what that means? But do m2.
Okay.
Now, I'm going to let you guess. What do you think that means?
That it hit it twice.
It counts it twice. Now, I can explain this to you graphically because it comes up later in the lesson. And I'm going to show you, algebraically, we found it. That m2 stands for multiplicity 2. It just means it happened twice. Happened 2 times. Okay, so now look at the graph. I want you to look at the zeros at 2 and at 3. Do they look exactly the same or do they look slightly different? They look slightly different. This 0, the first one at 2, you see how when it came through it, it passed through the x-axis? If it passes through, it's always an odd number. Whether it's a multiplicity of 1, multiplicity of 3, if it passes through, it's always an odd number. If it were going to be a 3 or greater, it would make like an S-curve. But did this make an S-curve? No, it just crossed straight through it. So you know it has to be multiplicity 1. It only occurs twice. Now, come to the next one. At 3, this does not cross through it. Guess what it does? It makes somewhat like a parabola. If it makes a parabola, you have to have at least 2 powers, and it has to be an even number. You get 2 powers of it, 4 powers of it, 6 powers of it, and so on. This one, how many powers did it actually have? 2. So how many unique zeros do we have? How many unique zeros? That means brand new numbers. 2. We have 2 unique zeros. How many real zeros total would you count? You would actually count them as 3 because of the multiplicity. That one counts twice. So if I ask you this question, here's why I say this. Is here in a second I'm about to show you imaginary zeros and irrational zeros. If I ask you how many unique real zeros does this have, your answer should be, say 2. 2. How many total zeros should this graph have considering it was a cubic function? How many, come on, wake up. How many total zeros should this have? 3. So if I only speak and say there's 2 unique, but there's 3 total, that would leave people thinking there's 1 out there that we haven't found yet. You see what I'm saying? If I just said 2 unique, but that there's 3 total, you think 1's floating out there. The reason we put multiplicity is so you know it's not just floating around that we solved for it. How many real zeros did this one have? Not unique. How many real? You're going to say all 3 were real. Irrationals and imaginary zeros are going to come in pairs. Now talk to me about pairs. What do we have pairs of? We say pair of jeans. Why do we say pair of jeans? 2 legs. We say pair of shoes. Why do we say pair of shoes? 2. And they match each other. There's this opposite direction. That's the only thing. We're going to have pairs of those, which means they're going to match each other. So a lot of information here, but it's very important to grasp this. I'm going to give you an imaginary zero. You ready? The imaginary zero is 2i. If you have one imaginary, you have to have a pair with it. You would have, what's the opposite of a 2i, do you think? Negative 2i. If you have a 2i zero, you're going to have a negative 2i. I'll give you a rational this time. Let's say square root of 7 is a 0. If square root of 7 is a 0, you'll also have its pair. What's the opposite of a square root of 7? Say negative square root of 7. Negative square root of 7, that's it. So what if you have a square root of 11 as a 0? What we also have. Wait, what would you also have? You have a square root of 11 as a 0. You'll have a negative square root of 11. Okay, let's try this one. What if you have 5 as a 0? Wrong. Why? What is it goes in pairs?
Irrational.
Irrational or imaginary. Is 5 irrational?
No.
No. So this only is true for imaginaries or irrationals. Now you know why I started the lesson with all those words. Okay? Some of y'all are looking at me like crazy. Just hang with me. It'll never make sense to you, or it'll make sense tonight, and it'll be easy for you. I don't know, okay, so just keep working, and hopefully the latter will come true. All right, we're going to do a few more of these, and then I'm going to give you some time to practice, because I think we need that. Let's look at this one. It says find the zeros here. All right, our list will be very short. How do I know that? What is my P in this problem? But P is 1. What's our Q? All right, so our possible rational zeros. It'll be the factors of 1 divided by the factors of 4. What are the factors of 1? Just 1 times 1. It's positive and negative. Positive times positive, 1. Negative 1 times negative 1. Asif, stay with me, please. Keep right. And what are the factors of 4? 1 times 4 and 2 times 2. Do I need to write 2 on there twice? No, don't have to write 2 on there twice. So now we simplify. I'm going in order, smallest to greatest. What's 1 divided by 1? 1 divided by 2? Nope, not 2. 1 divided by 2? And then 1 divided by 4. Now, because I was dividing, I actually went, that would not be, well, I guess negative 1 would be smallest. But either way, there's our list. How many potential zeros that are rational could this have? How many different locations?
3.
Would it only be 3?
No.
Because of positive and negative. You could have 6 different locations. Only 6. It could hit at 1, could hit at negative 1, it could hit at 1/2, negative 1/2, 1/4, negative 1/4. All right, let's look. Let's go to our graph. This time I will just clear mine out so I get all zoom back to normal. Add a graph. The equation was 4x to what power? 4x to the 3rd power. Okay. Minus 8x squared. Ah. Oh, and I forgot the x. Plus 8x squared. Okay. Plus 5x. Okay. Pauses all the way across. I'm going to hit enter. Ooh, I'm going to zoom in one time so I can see this well. Zoom in. Right there. All right, let's see how many zeros we have here. Menu, analyze graph. 0. How many unique zeros do you think we're going to have on this picture? 2. Now, how many total zeros will there be on this problem? 3, because that's the degree. It'll all. The reason I say total includes, or I could say complex, real plus imaginaries. Whoops, analyze. 0 one more time. Let me put this one over here. Okay, so there's that 0. All right, we're going to work our way through. Just to see what it looks like, do y'all want to pick a number that's too big and do synthetic to see what happens with the pattern if you take a number that's too large? What number is larger than both -1 and -0.5 that's on the list that you'd like to choose? How about +1? Let's try +1. If we tried +1, we would have 4x cubed, 4x cubed, 8x squared plus 5x plus 1. Let's see what happens if we choose a number that's too big. 4 drops. What's 4 times 1? 8 plus 4 is 12. 12 times 1?
12,
5 plus 12 is
17.
17 times 1?
17,
1 plus 17? That's our remainder. Is that good for a 0?
No.
Not a 0. Nor is it a factor, since r of x does not equal 0. Okay. Look at the pattern of our coefficients left over. What can you tell me about those? They're all positives. So what's the rule? If you get all positives, the number you chose is too big. What if the number you chose is too small? They would all alternate. They would alternate. So that's how it works. If it's too small, they'll all alternate. If it's too big, they'll all be positive. All right, so that one didn't work. Let's start with what should we have chosen? Going by the picture. -1. So we try -1. 4, 8, 5, and 1. 4 false. What's 4 times -1? 8 minus 4 is 4. 4 times -1? 5 minus 4? 1 times -1? And what do we get? 0. Is that a factor?
Yes.
Yeah. Now, that's a 0. That's not all positives. See, that's a 0. So you couldn't use that rule here. This is a 0. It's a 0 or a factor. Okay, so this was x cubed. What is it now? And that would be an x. Okay, let's just continue on. We know that -0.5. What is -0.5 as a fraction? Yeah, let's use that. Okay, so draw my line. I drop the 4. What's 4 times -1/2? You go 4 divided by 2, which is 2. Multiply that by -1. I'm getting -2. What's 4 minus 2? Positive 2? 4 times -1/2? -1. And 1 minus 1 is? Again, this is our remainder. We're not quite done, though, if you leave it like this. What's wrong with leaving it like this? The error fix. We have to divide this by 2. So the last factor would be that 2x plus 1 equals 0, and you would solve that.
Would it be negative though?
4 minus 2 is a positive 2. So it should be 2x plus 1 equals 0. Now how would I solve from there? No, you don't divide. You just divide by the denominator.
Okay.
No, not the great question, the error fix. You don't take the negative. Let me write that in there. Error fix. So we were supposed to divide by 2. This 4 did not get divided by 2. The problem is you can't do it right away, because if you do divide it right away, you get 2, and when you multiply that, you get a -1, and the numbers don't work out. You do it at the very end. All right. So how do I solve this one? Add 1 or subtract 1? Subtract 1. So 2x equals -1. Divide by 2, and what are we left with? That's right. Let me move this out of the way here. We have x equals -1/2. So if we wrote out all of our zeros, we have -1 and we have -1/2 twice. So what do you do if you have it twice?
Cross it out.
Put m2 in parentheses. m2 means it happens 2 times. So just to be clear on...
Would it be possible to have an M3?
Oh yeah, we're going to see in a second. You could have M7s, M8s, M9s. You could have anything under the sun.
How'd you get into
M2 means it happens twice. Not 3 times, not 4 times. It happens twice. We had 1/2 right here, right there. We had 1/2. We also had 1/2. I said 1/2. Correct me.
-1?
Negative 1/2. We have -1/2 right there. We have -1/2 right there. How many -1/2s do we have? 2. That's why we put M2. If we had it 3 times, we would have put M3. Okay, so clarifying language here. How many total zeros does the problem have to have if the power is a 3? 3. Do they all have to be real zeros?
No.
That's why, if you remember, last class, I was saying possible real zeros because they might be imaginary. They might not be real at all. They could be irrational numbers that we haven't seen yet, but that would be considered still real. So there's going to be 3 total. When you add them all up, there'll be 3 total. How many unique zeros do I have written there? 2. Would they only count as 2 real zeros, though?
No.
They would count as all 3 of the zeros. Why do they count as all 3? Because -2, -1/2, I'm sorry. -1/2 occurs how many times? Twice. Could you determine that looking at the picture? Could you realize that one of those was going to count more than once?
Yes.
Yes, you could. At -0.5, what's happening on the graph right there?
It bounces.
It bounces. That's the exact word I went out to use. It's on the notes. It'll say bounces. If it bounces like that, you know it has to be counting an even number of times. Either 2 times, 4 times, 6 times, something like that. If it crosses through it, it has to count an odd number of times. 1, 3, 5, 7, something like that. So if it crosses through, how many times will it count? An odd number. If it bounces, an even number. You got it. One last thing I meant to say earlier. On the last problem, I don't know if you probably don't remember. If you watch this video later, you'll hear me say it. I looked and I knew we had a problem, and I zoomed in. I knew I had a problem because I only counted, when I saw the picture, 2 zeros. I knew there was supposed to be a total of 3. The thing is, imaginaries come in pairs. So it's going to be impossible to only have 2 reals with 3 total, because you cannot have 1 imaginary. It's almost like coming to school with only 1 shoe on. You can't do it that way. You got to wear both share. So imaginaries and irrationals are always in pairs. Always. They're never an odd number of imaginaries or irrationals. That's helpful information for later on. A lot of information today. All right. Imaginary zeros. We've been talking about it. It's time to get there. And when you look at this picture here, how many zeros do you see on this picture? 2. Would those count an even number of times? Like maybe this one counts as twice, this one counts as twice. Could that be the case?
No.
No. It's only going to count 1 and 1 because it's not even making a curve. It's just crossing right through it. So that's 2 zeros. How many should this one have?
4.
4 total, which means there's 2 floating around there. These would be called imaginary because you don't see them. Imaginary ones you cannot see. Irrational, we will be able to, the square root of 7, something like that. We'll see it. It's just going to be a weird decimal. Imaginaries, there has to be 2 imaginaries here. Okay? So there has to be 2 imaginaries. This one, it crosses, and it tells you right here, there's 6 possible rational roots. Does it hit at any of those rational roots? Does this hit at positive -1, positive -2, or positive -4?
At this time.
Let's find out where these zeros are. Okay? Come on now. Wake up. So I believe I copied this equation out. Yeah, I did. So go to your next slide. So this is the same equation just from the previous slide. It says, suppose you were told that 2i is a 0. So 2i, what type of number is that?
Imaginary.
That's an imaginary number. Let's say we were told that 2i is a 0. Imaginary zeros come in what's called conjugate pairs. That means if you have 2i, you also have to have negative 2i. With this knowledge, let's factor that. So check this out. We're going to start, we're not going to graph this one. I'm just going to use 2i. I know that's a 0. Now let's write down our coefficients. How many x to the 4th do I have? 1. How many x cubes do I have? Not 1. Try -1. Good. How many x squareds? 3. How many x's? And what's my constant? All right. Leave a space. Draw a line. We drop the 1 down. What is 1 times 2i? And let me write up here in the corner that I is equal to the square root of -1. You'll need to know that in a moment. But I equals square root of -1. And now let's do some crazy wild math. What would I squared equal? If you square a square root, what happens? They cancel, so what's left over? That's going to be very helpful for us in a moment. I was being facetious when I say crazy math. All right, what's 1 times 2i? No, 1 times 2i. 2i. Are these like terms?
No.
No, so they stay separate. Typically, we write the real number first, the imaginary number second. That's typically the order. Now, we're going to multiply -1 plus 2i. And I'm going to do it over here to help you out. 2i times -1 plus 2i. You distribute that. What's 2i times -1? Okay, you'll start seeing a pattern in a second. What's 2i times 2i? Not just 4i, 4i squared. Well, we know what I squared is.
So -4.
Which is going to equal, I'm going to substitute this time. What does I squared equal to?
-4.
It's going to be -2i plus 4 times -1. Now I'm going to simplify that right over here. What is 4 times -1? I'm going to do the real part first, the imaginary part second. What's 4 times -1? -4, and then minus 2i. So you'll get the pattern. The pattern's this. When you multiply, it's going to be the same. What was 2 times 2? 4. But the sign, when it's I times I, you just switch the sign. So that'll be the pattern. What is 3 minus 4? So put down here -1. And then minus 2i is on its own. It's its own like term. So we multiply this again. We just multiplied that. Almost that. What is the -1 times 2i going to be? That's the -2i. Leave space in the front for the real. 2i times -2i is -4i squared. 2i times -2i is -4i squared.
And then I squared is equal to -1, and then -4 times -1 is positive.
There it is. He just rattled that off. I don't know if you caught that. That was crazy. Again, if you wanted to multiply it over here, 2i, that's an ugly I, 2i times -1 minus 2i, that was equal to -2i minus 4i squared, which became 4 minus 2i, because I squared is equal to -1. Okay, so now I simplify here. What's -4 plus 4? 0. So you don't even have to write the 0 because I have minus 2i. So we'll take away the 0. Now -2i times positive 2i. What's -2i times positive 2i?
-4i squared.
Now I could write it, but that's not how. -4i squared would not stay that way. It would become positive 4. Now what do you get?
0.
So is that a 0?
Yes.
All right, that's good news. Believe it or not, that was crazy. It worked. That's a 0 or a factor. Your brain hurts? All right, well, we found one imaginary 0 did actually work. Ladies first. All right. Well, if 2i is a 0, what also has to be true?
-2i is also a 0.
-2i is a 0. Let's try that one out.
Oh, God. Even more.
Oh, we're not done yet. There's more. I feel like it's one of those infomercials on TV.
Sir.
Drop the 1. And just to keep track, this was a 4th power. This is now a 3rd power. This will be a x squared in a second. What's 1 times -2i? Now you'll like this one more because what happens here?
Oh, it
Cancels, but the -1 drops. What's -1 times -2i? -1 times -2i becomes positive 2i. What happens here? Those cancel, and I have a -1. What's -1 times a -2i? And what's a -2i plus 2i?
0.
Like I said, every imaginary should come in partner. If you don't get 0, we did a math error. So this is a 0 or a factor. So what's left over? This was 1x cubed. This is now x squared and x. Do I need to do an error fix here?
No, it's not a fraction.
It's not a fraction. Don't have to do an error fix. Okay. So to finish this off, here's where we are at this stage. If we were factoring this, at this stage, we could say that f of x is equal to x equals 2i is the factor x minus 2i. X equals negative 2i is the factor x plus 2i, because remember, it lies whenever it goes to parentheses. And then this, x squared minus x minus 1. That's where we are at this stage. Now, is that completely factored?
No.
No, because of this x squared. So I'm going to give you another method here. Do you remember, the reason I say this, we could do x method? What are factors of negative 1? That add up to negative 1.
Positive 1 and negative 1.
Do those work?
No.
That multiplies right. Do they give a negative 1 here when you combine them?
No.
There's not any that are rational. So this must be irrational. You haven't seen this yet. The, I don't know, what is this, fifth technique? We're going to use quadratic formula. They'll say. The quadratic formula. You remember the quadratic formula? All right. This will work.
X squared.
Quadratic formula works on anything that's quadratic. X equals negative b plus or minus square root b squared minus 4ac all divided by 2a.
Oh, God.
Yeah, there we go.
Do you remember that formula?
Yeah.
Yeah.
I wish I did.
If you don't, go get it tattooed up on your arm by next class. This one's an important one to have down.
I will have it tattooed when I'm dead.
Don't do that. But how about just memorize it? All right, so we're going to find our other zeros here. So it will be x equals, it's negative b. What's my b? Let me go ahead and put this in here in case you forgot. A, B, C.
So it would be
Positive
positive
1.
It would be a negative of a negative 1. What's the negative of a negative 1?
Positive 1.
A negative of a negative 1 becomes positive 1. I'm just going to erase that and put positive 1 plus or minus. This is the pair. Remember how I told you they come in pairs? Positive and a negative. There's your pair. Square root. What's b squared?
Oh, it's this one.
Negative 1 times negative 1 is 1 minus 4 times a. What's 4 times 1? 4 times negative 1. Negative 4. Okay, so it's 1 minus a negative 4. What does that become?
1 plus 4.
1 plus 4. All divided by 2 times a, which is 2. I only need to write that 1 down. It's just 2. Let's simplify, and we'll have our last. This, by the way, is going to be an irrational 0. It's a real 0, but it's irrational. 1/2. I'm simplifying. With fractions, you're allowed to divide them apart. It's 1/2 plus or minus. What's 1 plus 4? Ooh, that was mental math like crazy right there. Square root of 5 divided by 2. There's your zeros. Okay, so these are zeros here. That right there, just to make sure, those are zeros. So in factored form, here's how it look. F of x would equal, for the 0, 2i, you would have the factor x minus 2i. For the 0, negative 2i, you would have x plus 2i. For these are the zeros. So as it goes in the factor, you have to switch signs because you would move it over to the side with x. What's the opposite of a positive half? Negative 1/2. I'll take the positive square root of 5 over 2 first. That becomes a negative square root of 5 over 2 times. There's a second one. This counts twice. There's a positive and a negative. So once again, 1/2 becomes negative. But this time, I'll take the negative square root of 5 over 2, which becomes, in the parentheses as a factor, a positive square root of 5 over 2. Said another way, once I write all this down. Irrational factors and imaginary factors always come in conjugate pairs. They always come in, starts with the P. What do they come in? Pairs. I say conjugate, which means the irrational part or the imaginary part switches. Not the real number portion, but the the irrational portion or the imaginary portion. Look at our answers. 2i. What type of number is that? I mean,
Imaginary.
that's imaginary. If it's imaginary, you have a negative 2i, you also have to have a positive 2i. Okay, look at the next two parentheses. Negative 1/2. Rational or irrational?
Rational.
Rational. So that one's not going to change. It was a negative 1/2 there. Notice, is it a negative 1/2 over there?
Yes.
Did that part change? Stay with me now. Stay with me. I know it's a long lesson here. Does the negative 1/2 change?
No.
It stayed the same. Why did that part stay the same?
Rational.
That was the rational part. It's the irrational part that switches. I have a negative square root of 5 over 2. The square root of 5, that's the irrational part. That's a never-ending decimal. It doesn't repeat. Negative square root of 5 over 2, and I have a positive square root of 5 over 2. So if you found 1, you actually found 2 because it has a conjugate pair. Conjugate just means you switch the sign. So if you have a positive, you'll also have negative. When do we have conjugate pairs? On real numbers?
No.
On whole numbers?
No.
On natural numbers?
No.
On irrational numbers?
Yes.
Yes. And
Imaginary.
imaginaries. Got it. You got it. Wasn't this fun?
No, it was not.
All right.
I can't wait to have my hair.
Let's find the roots. We'll do this in quickest fashion possible. Number 1. You may. I should say number 10 here. Number 10. Can I, the reason I said number 1 is I'm going to go in order. Do I have a GCF here? Can I factor something common out?
No.
No. So then you take, can I do X method?
No.
No. Can I do synthetic? Maybe. But to do synthetic, we either got to write out our rational roots or go to the graph. Let's go to the graph. Whoops. If the question is, did you learn something today? What's your answer?
Yes.
Jesus Christ.
Jesus Christ. Hey, he's a great savior, but best I learned, he saves you from sins, not from math. So, why do we say that? Have you ever thought, why don't we just say, oh, Gandhi, oh, Muhammad? Why is it Jesus Christ? Probably not. I think he's the only one with power. I don't know.
It's offensive to some people.
Probably the only name with power. That must be why. I don't know.
It's a discussion. It's going to go one way or the other.
All right. I have the equation typed in. Before you hit enter, what's the maximum number, or what's the total zeros we're going to have here? Total count. 4. How many of those appear to be real? 2. Let's find out if they're rational or not. We'll know it real quick by our list. So, by the way, if it's not real and you can't see them, they have to be imaginary. Irrational, you will still see. It's just going to be a crazy number, a crazy decimal. This appears to be crossing at 2. And now, is this going to be rational or irrational?
Irrational. No, rational.
Could we have on our list a negative 1/3? Could I get a 1 from here? Is a factor of negative 4 a 1? Yeah. Is a factor of 3 3? So I can have a negative 1/3. That's rational. This is rational. I don't see any others. That means the other two have to be irrational or imaginary. Which one? Imaginary. It's going to be imaginary. Okay, so let's do our math. So the only way I know to simplify this equation from here is to start with synthetic, and we know where to start from. What do y'all want to divide with first? Negative 1/3 or 2? I like 2 as well. Let's start with a simple number. My coefficients are 3, negative 2, negative 1, negative 12, minus 4. Hey, I got a question for you before I continue. What if you did not see an x squared up there at all? You would put a 0 in its place.
Oh yeah.
You would put a 0 in its place. You would have to have that 0 to get the correct answer, by the way. Have to. All right. Here we go. I drop my 3 down. What's 3 times 2? 6. Negative 2 plus 6?
4.
Negative 4 or positive 4?
Positive.
My error. Okay, 4 times 2? 8. Negative 1 times plus 8? 7. 7 times 2 is 14. Negative 12 plus 14 is? And 2 times 2? 4. What do we get there? 0. If you get 0 there, it is a 0 and a factor. Good. Okay, where are we going to go with next? And just keep track. This was a 4th power. This is now a 3rd power. We got 3 more zeros to find out of here. Am I going too fast? You're not able to think?
Yeah. What's it? Oh.
Well, we're still going to go fast. This decimal here. Negative 1 over 3. Good, Pedro. I heard you first. Heard a lot of people. Pedro was quick on the call there. All right. We drop that 3 straight down. Do I divide now?
No.
Can I do my error fix now? No, it'll mess up all these numbers. So you wait on your error fix. Error fix. What is 3 times negative 1/3? If you're not sure, this, since I'm multiplying by 1 up here, all you got to do is divide by negative 3. You can ignore the 1. Just multiply by 1 and 1 will change it. What's 3 divided by negative 3?
Negative 1.
Negative 1. 4 minus 1?
3.
Same number. 3 divided by negative 3. 7 minus 1 is? Okay, this time it's 6 divided by negative 3. Negative 2. Excuse me, 2 minus 2 is? Ooh, good news. This is,
Yeah.
oh, good call, good call. Error fix. Our error fix, when we drop our power down, this becomes x squared, but we need to divide it by 3. Because that 3 did not get divided, and yeah, you do these as well. By the way, if you did have a remainder, you would not touch the remainder with that. You would only do these numbers. So we now have x squared plus x. Now, we already know from the picture this will not be real, but just think about it. Factors of 2 that add up to 1. Someone's going to say 2 and 1. What's the problem, though?
They don't add up to 1.
They don't add up to 1. They add up to 3. So what if he said 2 minus 1?
Yeah, wait, no.
That would multiply to be
Negative 1.
negative 2. So that doesn't work. So what do you use for a trinomial if x method doesn't work?
Oh.
Quadratic formula. X equals negative b. Let me write this in. A, B, C. What's our negative b? B is 1, so it's negative 1 plus or minus square root b squared. What's our b? 1, so square it. 1 minus 4 times a times c. What's 4 times 1? 4 times 2. 8. All over 2 times a. What's 2 times 1? 2. All right, we'll simplify that. The real number portion would become negative 1 over 2. That's the part that will not have a conjugate pair. It'll just be itself twice.
Yep.
Conjugate pair portion. 1 minus 8.
Negative 7.
Okay,
Yeah.
So-
7.
so it's the square root of negative 7.
Negative 7.
It's the square root of negative 7, which I'm about to show you what that is in a second.
Over 2.
Over 2. Now, are you allowed to take a square root of a negative number?
No.
That's what the imaginary is. So last time, here's how you rewrite this. Negative 1/2 plus or minus. Put the I out front. Square root negative, not negative 7, I'm sorry. If you take the I out, you just say square root 7 all over 2 like that. You take the negative out, and you replace it with the I. So what are the roots? What's a synonym for roots to make sure we get the correct answer here? 0. The zeros would be x equals, not negative 1/2. So going in order that we solved, we had 2 followed by negative 1/3 followed by negative 1/2. And you can do this as a plus or minus. That's acceptable. I squared of 7 over 2. Question for you. Listen to my words closely. How many total zeros is that? 4. How many are real? 2. How many are imaginary? 2. Do we have any multiplicities? No, because we'd have to put parentheses, M2, M3, whatever. That's 4 total zeros, 2 imaginary, 2 real. Anything else want to say on that? No, but for good practice, in factored form, here's how the equation would look. In factored form, it would be g of x equals x plus 2 or minus 2? X plus 1/3 minus 1/3. Wrong. You'd actually write it this way. If it's a fraction, you'd multiply by 3. 3x. And then add the 1 over. It would be 3x plus 1. That's how that would look. That's where that would come from. You'd multiply by 3, then add 1. And then the last one,
2x plus 1.
you know what? I didn't do that right before. I should have done it this way. It would be 2x, because you multiply by 2, plus 1, and then you do both the positive and the negative version. So it'd be I squared root of 7 and 2x plus 1 plus I square root 7. Is that not fun, or is that fun?
No.
No, I'm wrong on that. You wouldn't do that on imaginaries, because I'm looking, if I multiplied the leading terms, I would not end up with 3x to the 4th. Check that. Sorry. This is not accurate. This was the way we had it before. That would have been an error. You don't do that on imaginaries and the conjugate pairs. It's just negative 1/2 minus I squared root of 7. Sorry, plus over 2 and x plus 1/2 plus I squared root of 7 over 2.
Isn't the difference supposed to be a negative 1 over?
The sign changes when you add it across.
What do you mean?
To put it with x. As a factor, notice there's no equal sign in here. There, you have to get them on the same side, so you'd have to add the 1/2. Great question, but that's why. So notice how all the signs switch. The positive 2 becomes a negative 2. The negative 1/3 became, I know it's 3x plus 1. It became positive. This negative 1/2 becomes a positive 1/2, and that does not change because that's the real portion of it. The imaginary portion does change as the conjugate pair. You have one that's negative, one that's positive. Goodness gracious. So now we're finally to multiplicity. I've already talked about this, so I'm going to skip this slide. This just tells you put in parentheses m with the power that it is. All right, so if a linear factor is repeated, then you say it has multiplicity. All right, so on this one, example 11a. For this, determine the zeros and state the multiplicity. How many zeros would this have? What do you think?
3.
4.
The numbers just keep going higher. It was 2, then I heard 3. Now I'm hearing 4.
It's 3.
4 is the correct answer.
4.
4 is the correct answer. Let's see where the zeros would be. We're using the zero product property would state to take each factor equal to 0.
X is equal to
Each
0.
factor and set that equal to 0. So x minus 2 equals 0. Because it's squared, you would do it twice. And notice that's going to be 4 zeros. This one's already solved. This one's not. How would I solve this one? Minus 1. We do the opposites. So 3x equals negative 1. And then finally, divide by 3. So what does x actually equal here? Negative 1/3. Okay, come over here. Add 2. And we get x equals 2. And then on its square version, its second version. What do we get there? Okay, so what are the real unique zeros? There's 0. Yeah, there's 3 total, 3 unique. That's right, 3 unique. There's 0, there's negative 1/3, and we have 2 twice. Since 2 is twice, you don't have to write 2 comma 2. Instead, you write 2 parentheses
M2.
M2. What does that mean? It happened 2 times. So it says determine the zeros and state the multiplicity of any repeated zeros. You only do it on the repeated. So one more time on words. One more time on words. How many unique zeros do you see? 3. How many real zeros are there? 4. You count that multiplicity twice. Okay. So the reason I state that is because total zeros are 4. There's nothing left over to be imaginary or irrational. Nothing left over. They're all within those 3 unique ones. They count as 4 because of multiplicity. All right. Let's try part B. We're going a little faster now. This part's great. Let's try it again. Oh, yep, going too fast, sorry. Too fast. What did ZPP stand for?
Zero product property.
Zero product property, good. Zero product property. From Algebra 2. All right, let's do it again. According to the zero product property, you could take each factor and set it equal to 0. Now, this time, do I need to write x plus 2 twice? Do we really need to do that? No. We'll just write the multiplicity in a second. So I'm going to write each one unique factor down. That's all I'm going to do. Now this one occurs 3 times. This one should occur 3 times. And how many times occurs? Sorry. How many times would this occur? Okay, I'm just going to make the note here instead of writing it out. Okay, let's solve. How would I solve 3x equals 0?
Divide by 3.
Divide by 3. And what do we find out x equals? Good. Go to the next one. How do I solve this one? Minus 2. So x equals negative 2. Good. And finally, add 1 to both sides. 2x equals 1, and so you divide by 2, because 2 is multiplying, you do the opposites. We get x equals 1/2. So the zeros that we have, 0, negative 2. Now what did it mean that it occurs twice? So we'll do parentheses, M2, comma, and 1/2.
M3.
Occurs 3 times, so it would be parentheses.
M3.
All right, let's count them up here. If I said, if you listen to the words closely, if I said how many unique zeros are there, the answer is 3. It would cross the x-axis 3 separate times. If I said how many real zeros are there,
6.
good math. 1, 2, 3, 4, 5, 6. You got it. 6. All right, now let's look at some pictures. We talked about it earlier. If a graph bounces, you have to have a minimum of 2, but it'll be an even number if the graph bounces. If it crosses through, if it's a straight cross through, it'll actually just be a multiplicity 1, meaning it occurs once. If it's 3 or some other higher number, it'll do like an S curve through the point there. And again, the degree, you could add up the powers to figure it out. Okay? So here, we're just going to, instead of finding the zeros, we're going to go graph this one. X cubed minus 6x squared plus 32. New document. Don't save. It was x cubed. How many total zeros will this have?
3.
3. X cubed plus, what was it?
Minus 6x squared.
Minus 6x squared, okay.
Plus 32.
Plus 32. All right. Take that graph. How many unique, listen to my words, how many unique zeros do you see?
2.
2. So they count that as 2 real zeros?
Like in total?
Yeah, in total.
Oh,
Alright, Gabby says no.
Let's do it too.
Would you count as 2 real zeros?
No,
How many unique zeros?
2.
2. When we're counting up our total number of zeros, how much would this accumulate?
3.
Why 3? What do you see?
I said about 3.
The bounce. That bounce here.
Please by the direction. Teachers, please check your email from Ms. Begg.
It counts as how many?
2.
2. So this would have 2 unique, but we've counted as all 3 zeros. All right, so let me just copy this over. Whoops, sorry. Copy it over, and let's write it in. So for you, just do a quick sketch. Doesn't have to be anything brilliant. Just copy it in and sketch it on your paper. This 0 occurs where? At -2. This 0 occurs at 1, 2, 3, 4. So if you were going to write the equation, and we know this is an M2. I know it's M2, not M4 or M6. How do I know it's an M2?
Because it bounces.
Curve.
It doesn't.
As opposed to a different even number. Sorry.
It doesn't.
What's our degree of the original function? 3. The degree is 3, so we have to add up to 3. So that's why I know it can't be a 4 or 6, something like that. Okay, so on this one, it says find the zeros. We said the zeros are -2 and 4, and we're going to say M2. If you were to write this as an equation in factored form, it would look like this. It would equal, what was the factor if you had a 0 of x equals -2? Very good. And what would be the factor if you had a 0 at 4? Now what would it be since you know it's a multiplicity of 2?
X squared.
Squared. There you go. Good. That would be the equation right there. All right. I think we've used the calculator a lot. So we're going to skip on down. You can go back later and watch the videos and I'll fill this in. Last 3 examples. Example 13. It says write an equation of a polynomial function whose only roots are x equals 5, multiplicity of 5, x equals -1, multiplicity of 2, and x equals 2, multiplicity of 3. You go ahead and write out what you think this would be. I'll give you just a few seconds. Few seconds. You write out what you think it is.
Give us at least 2 minutes.
Well, I'm going to write up here, but I'm going to pause your screen so you can't see it. You write what you think it's going to be. All right, I wrote mine. Alexis. Come on, write out your what you think it's going to be.
Well, we are close to people being
All right, what value do you think, or what did you write for your equation?
X minus 5 to the power of 5. X plus 1 to the power of 2.
X to the
And
power
X
of 10.
minus 2 minus the power of 3.
Like, well, my remote's not working anymore.
Wow.
Come on, wake up, TV.
There we go.
There you go. Like that?
Yeah.
All right, all right. That would be A. Okay, what about part B here? Again, I'm gonna freeze. Well, get it from what's given to you. All right, let's try this again. I'm gonna, if this my remote will work here. There we go. Froze it for you. Go ahead and write out what you think your equation is. more seconds.
Oh, no, wait, it's right. Okay.
All right. This one.
Yeah, okay, that makes sense.
You ready?
Yeah.
Check your work against mine. If I can unfreeze it. There you go. So I put my x out front. This wouldn't be required, but I put my x through 0 out front. The x plus 5, I squared it. Why did I square it? Because it bounced. All right, the x plus 2 factor from -2, I cubed it. Why did I cube it?
Because of the S.
Because it kind of makes an S curve there. And the others I did, the others just crossed through, so I did it all without a power. What about 3?
How do you get the, like, we need counters and inputs, right?
This one, how do you get a power 3? Is that what you're asking? Okay, because it kind of makes an S curve there. I know it's not the clearest picture, that's why. Okay, and the last one, what we would do here is if you have a value, here's what I have not told you all day. You could have a capital letter A at the very front that you have to solve at the end. What you would do here is after you write your factor form, you would put a capital A at the front and you solve it there. But we're out of time, so